Alrighty, in this video, we're going to be learning about 4.3 quadratic functions. A big thing here is just note that a quadratic function in standard form is written as ax squared plus bx plus c. This again would be standard form. It's standard form because it goes from the highest degree to the lowest degree in that receding order. The other thing you need to know is the vertex form. And it is f of x equals a times x minus h squared plus k. This would be the vertex form of a quadratic. If it's in vertex form, the vertex is just h comma k. Notice it's the opposite sign of the h. But if it is in standard form to find the vertex, you need to know what negative b divided by 2a is. So they're coefficients. That would be the x. And then once you have the x, then you're just going to plug it back into the function. So whatever you get for your x, plug it in, and then you have your y. So that's how you find the vertex if in standard form. If it's in vertex form, you can just pull the h and the k straight out of your work. And then there is a quadratic regression. If we get to that, I will show you again by calculator, just in case you didn't catch that last little video. We'll figure out how to maximize and minimize problems. That's where it gets famous here, those type of problems. All right, so let's kind of just jump right into it. So let's look on page 264. We're going to be on problem number 1. In this, it says graph the following quadratic functions, accurately locating the vertices and x-intercepts. So we are given f of x equals x minus 2 squared plus 3. Now it's asking us to find the vertices. So the vertex here is just going to be whatever this opposite of this number is. So that's 2, comma, whatever this number is, which is 3. So you just change the sign of the h. There's your vertex. To find the x-intercept, you have to let y equal 0, or also known as f of x equal to 0. So what we do is we take this function, we're going to set it equal to 0. So 0 equals x minus 2 squared plus 3. So I'll subtract 3 on both sides. And then I'll take the square root. But at this point, I can't take the square root of a negative number. So there is no x-intercept. To make this quick, if these are both positive, like there's an a here that's positive and this is positive, like we see here, there will be no x-intercept. And if they're both negative, there will be no x-intercept. So if both the a and the k are the same sign, no x-intercept. Right, just to save yourself some work. All right, so I was not able to find any x-intercepts, but let's talk about how to graph this now. So I start with the vertex. So 1, 2, 1, 2, 3. Just locate it right here. Then just pick the values to the left and the right. It makes it super easy. If I choose 1, it's going to be 1 minus 2 squared, which is 1 plus 3, which is 4. So this ends up being 1, 4. If I pick 3, that's 3 minus 2 squared, which is 1. 1 plus 3 is 4. So you need to notice how this function opens. This is a if a is greater than 0, it's going to open upwards, which means it has a minimum. If a is less than 0, it'll open downwards, which means it has a max. So since this is positive, I know it's going to open this way. So I know it's going to open this way here. And then it's always going to go over 1, up 1, over 1, up 1, pending that a stays 1, right? As long as a is 1, it'll go up 1, over 1. And then it's real nice and easy. Just to help you out. to go faster in your work. Other than that, you can always just plug values. I would plug values to the left and the right of the vertex so that you're not dealing with too big of numbers. All right, let's look at some more. So let's look at number 2. 2 is g of x equals negative x plus 2 squared minus 1. Again, my vertex is going to be negative 2, negative 1. To change the sign, keep the sign. X-intercept, again, this is negative and negative. So if I was to add and then divide, I would end up back at a negative, and I cannot take the square root of a negative, so there is no x-intercepts. And so when I try to graph this, I want to go 1, 2, down 1. It's negative, so I know it's going to open downwards. So I'm going to go over 1, down 1, over 1, down 1. Check yourself if you need to. Negative 1 plus 2 is 1. Squared is 1. Apply the negative, so that's negative 1 minus 1, which gives you negative 2. Works every time, pending that a is 1. All right, let's try number 3. Number 3 is h of x equals x squared plus 6x plus 7. Not so easy on this one. So we have the vertex. It is going to be negative b divided by 2a. So here's my a, here's my b, here's my c. So I have negative b, so that's going to be negative 6 divided by 2 times 1. And then I got to figure out what that is. So let me kind of clean this up before I just automatically know what my vertex is. So it's going to be negative 6 divided by 2, which is negative 3. That is the h value or the x value of my vertex. So now take that and plug it in for all of my x values. So in this case, that's going to be basically what I'm trying to find is h of negative 3. So this would be negative 3 squared plus 6 times negative 3 plus 7. So negative 3 squared is 9 minus 18 plus 7. So that gives me negative 9 plus 7, which is negative 2. So that tells me my vertex then is negative 3 comma negative 2. So notice when it's not in vertex form, a little bit more work to determine what the vertex is, and then even more work to try to determine what the x-intercept is. Because now I have 0 equals x squared plus 6x plus 7. You could try factoring, quadratic formula, completing the square. I'm going to try factoring first, because that would be the quickest way. The only thing that multiplies 7 is 1 and 7. They both have to be positive, both be negative, so there's no way to do that by factoring. So then I'll try the quadratic formula. So that would be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 7 divided by 2 times 1. So negative 6 plus or minus, this will be 36. 7, 14, 28 over 2. So this gives me negative 6 plus or minus, what is that, 8 over 2. And so when I work this out, this is going to be 2 and 4, which is 2 and 2. So I can simplify this even more. So this would be negative 6 plus or minus 2, square root of 2 divided by 2. Simplify that, that's negative 3 plus or minus square root of 2. So there's your x-intercepts, there's your vertex. Now you got to be able to graph that. So graph it's a lot easier because once you have the vertex, go left 3, down 2, and then A is positive, so that still will apply. So I know I'm going to go up and over. So I'm going to go right here and right here. If you don't trust the process, again, you can plug negative 2 in. You would get 4 minus 12, which is 4 minus 12 is negative 8. Negative 8 plus 7 is negative 1. So I do, in fact, get negative 2, negative 1. So it does continue to work that way. So again, graphing, a lot easier than having to do all that. Alrighty. Let's see. Let's look at number 7. This is q of x equals 2x squared plus 4x plus 3. Again, to find the vertex, I need to determine my x, or my h, whatever you want to call it, which is negative b divided by 2a. So that's going to be negative 4 divided by 2 times 2. So that's going to be negative 4 divided by 4, which is negative 1. And then I'm going to take my negative 1, plug it in. So this gives me negative 1 squared, which is 1, times 2, which is 2. 4 times negative 1 is negative 4 plus 3. Negative 2 minus 4 is negative 2. Negative 2 plus 3 is 1. So therefore, I get negative 1, 1 as my vertex. And then, let's see, we need the x-intercepts. So then to find my x-intercepts, I do 0 equals 2x squared plus 4x plus 3. If I try to factor this, let's see, two numbers that multiply to 6 but add up to 4, impossible. So x equals negative 4 plus or minus 4 squared minus 4 times 2 times 3 divided by 2 times 2. So I get negative 4 plus or minus 16. That's negative 24 over 4. The moment I realize that this right here is going to be a negative number, I can say no x-intercepts, because 16 minus 24 would give me negative 8. So I could have stopped there the moment I saw it. So no x-intercepts. So then I just graph it. So that's going to be left 1, up 1. It's a positive, so it's going to go upwards. So it's going to go over 1, over 1. So right here and right here. Oh, but a is no longer, that doesn't work now because a is no longer 1. So in this case, I need to plug in the number. So if I plug in 0, I get 3. So it looks like I went over 1, up 2. So this now will always be true. If you do plug into 1, it's symmetrical the other way. So if you went right 1 over 3, up 2, you would go left 1, up 2 as well. So you find 1, the other one's symmetrical. All right, I do have a quick question. If I gave you a function like this, 8x plus 5, would this have a minimum or maximum? Like we see that this right here has a minimum. We see that this one had a minimum. This one had a maximum. This one again had a minimum. But if I was to graph 8x plus 5, so that'd be 1, 2, 3, 4, 5. And then I go up 1, 2, 3, 4, 5, 6, 7, 8 over 1. And we'll just roughly say that's the graph. Does this have a min or a max? Hopefully you're saying no. So a linear function does not have a min or a max. Right? There's a random question in your homework that asked this question, so I thought I should bring it up. All right, let's go back to our regular programming. So let's look at number 12. So we have p of x equals negative x squared plus 2x minus 5. So again, to find the vertex, I need to determine my negative b divided by 2a. So this is negative 2 divided by 2 times negative 1. So that's negative 2 divided by negative 2, which is 1. Plug it in. So that gives me negative 1 squared plus 2 times 1 minus 5. Ooh, what is going on there? 5. So that's going to be negative 1 plus 2 minus 5. So that's going to be 1 minus 5, which is negative 4. So therefore, my vertex is 1, negative 4. Again, I'm still asked to find for x-intercepts. So my x-intercept would be 0 equals negative x squared plus 2x minus 5. So let's see if we can factor that. That would be 5. Two things multiplied by 5 to add up to 2, impossible. So x equals negative 2 plus or minus the square root of, so negative b plus or minus square root of b squared. So that's 2 squared minus 4 times negative 1 times negative 5. divided by 2 times -1. I'm going to kind of look in here real quick. That's 4. And then that would be +4, -20. Yeah, that right there is going to give me a negative number. So there are no x-intercepts. All right, so then I graph the vertex. So 1, and then 1, 2, 3, 4. It's going down. It is a 1 there. So I know I can also just do this and be good to go. Let's do one more just to make sure you have them all. 14 is a little different. It says k of x is equal to 2x squared minus 4x. Nothing changes just because it doesn't have 3 terms. So the vertex is still going to be -b divided by 2a. In this case, that would be -4 divided by 2 times 2. So that's 4 divided by 4, which is 1. When you plug in 1 into the formula, you get 2 times 1 squared minus 4 times 1. And so this would give you 1 squared, which is 1. So it's 2 minus 4, which is -2. So I still get 1, -2 as my vertex. When I'm looking for my x-intercepts, this would be 0 equals 2x squared minus 4x. I'm going to pull the greatest common factor out, which happens to be 2x, and then I'm left with x minus 2. Set those equal to 0, so 2x equals 0, x minus 2 equals 0. So x equals 0 and x equals 2. So I have 2 x-intercepts there. And so I can graph both of those. So I can say I got a point right here and I have a point right here, including with my vertex of 1, -2. I have a graph that looks like this. All right, so hopefully that was a lot of good examples for you to see on that one. So let's go to a different type of questions you'll be asked. So let's look at number 20. So 20, you're asked, it says, for each of the following parabolic graphs, man, find a formula for the corresponding quadratic function, and then use the formula to determine the coordinates of the parabola's vertex. So again, first we need to find the formula of the quadratic function, and it doesn't give us the vertex. So this is what we're going to do. I wonder if it doesn't want us to estimate. Let's go back to example 3. So we're given our x-intercepts, and you just got to calculate the a. All right, so we're given the y-intercept and the x-intercepts. All right, so in our first step here, we would determine our equation. It's going to be a times our 0. So we have a 0 on number 20 at 1, 2, 3, 4, at -5. Nope, it's going by 2s. So 1, 2, 3, oh, and it's a 4 anyways. So that'd be -2. So we have a 0 at -2. So the factor there would be x plus 2. And then we have another one at 1. So that'd be x minus 1. So that's how it starts. And then we're given the y-intercept as well as 1, 0, -2. All right, so we use that first fact. So f of 0 equals -2. So now I want to plug in 0 in for x. So that means that a times 0 plus 2 times 0 minus 1 has to equal -2. So that's going to be 2 times -1. So that's -2a equals -2. Then we divide by -2, and a equals 1. So therefore, I now have an equation of 1 times x plus 2 times x minus 1. How far in detail do they want us to go with that? And they're good keeping it there. So I don't necessarily write the 1. I would just write it out like this. They do not require you to fold it all the way, or at least in my notes, they do not. So you're good there. If you did, you would just fold. All right, the next question to that. So that was part A. Part B was then to use that formula to determine the coordinates of the parabolic vertex. And that one, you're going to have to either put in vertex form or standard form. So we're going to have to fold this out regardless. So this would be x times x, which is x squared. Negative x plus 2x gives me 1x minus 2. So then to find the vertex, that's going to be negative b divided by 2a. So that's going to be negative 1 divided by 2 times 1. That's negative 1/2. Then I'm going to find what negative 1/2 is. And that's going to be negative 1/2 squared plus negative 1/2 minus 2. So that gives you 1/4 minus 1/2 minus 2. So that would give me negative 1/4 minus 2. And that right there would give me negative 5/4. So my vertex would be negative 1/2 and negative 5/4. All right, and again, we could have tried around about that, but we could have got wrong as well. So we just leave it like that. All right, so that's how you would do a question like that. After that, the rest of the homework is really just some word problems. So let's make sure we understand those. That's going to be it. All right, so first we have number 40. You are asked that the back of George's property is a creek. George would like to enclose a rectangular area using the creek as one side of the fencing for the other 3 sides to create a vegetable garden. If he has 300 feet of material, what is the maximum possible area of the garden? All right, so here's how you figure this out. So you have a creek, and then you have fencing. You don't know what the left side and the right side are, so you're going to call them both X. And then you're told that you have 300 feet of material. So whatever material you use here, you would do 300 minus those, but there's 2 of them. So you do 300 minus 2x. Now you're trying to maximize the area. So all you got to do now is just do x times 300 minus 2x. You might have seen this in your high school Algebra 2 course as well. It's one of the most famous questions that are pretty much like in every math course. I think even starts in Algebra 1. But then from here to calculate it, you want the maximum. So you need to find the vertex. So we're going to distribute this. So this is 300x minus 2x squared. I'm going to go ahead and put this in the correct standard form because as I'm looking for the x value so I can find the y value, which is the maximum area, because the x is just going to give you the lengths of the triangle, but the y would be the area of the, not triangle, the rectangle. So that's going to be negative 300 divided by 2 times negative 2. So that's negative 300 divided by negative 4. So 300 divided by 4. Not typing, that's awesome. 300, why are you not typing? 300 divided by 4. What are we doing? 300 divided by 4. 75. So 75 is my length of my side that would maximize my area. So then I just need to plug it into the equation. You can plug it into either or. I think I'm going to plug it into this one. I'm going to say 75 and 300 minus 2 times 75. So that's 150. So that would be 75 times 150. And that would give me, so times 150, and that would give me 11,250. So that would be your maximum area with that situation. And this is, again, you'll see this problem all over the place, and that's pretty much one of the most famous problems I've ever seen. Because I've seen it so much. And that's not just because I'm a teacher. It's as a student, I saw it so much. All right, so let's look at number 42. The next type of questions you see dealing with quadratics are the total revenues. So the total revenue for Thompson Studio Apartment is given by the function R of X equals 100X minus 0.1X squared, where X is the number of rooms rented. What number of rooms rented produces the maximum revenue? So again, calculate that negative B divided by 2A for the vertex. It helps to put this in the correct order so you don't make any mistakes on pulling your information, because it'd be negative 100 over 2 times negative 0.1. So I get negative 100 divided by negative 0.2. So let's pull up our calculator again. So that's going to be 100 divided by 0.2. So I get 500. So it takes 500 rooms to produce the maximum profit. And it's not asking for what the profit is, but just wants to know how many rooms rented. So do pay attention to what the question's asking. So in that case, that would be it. Let's do another one. Let's look at 43. This one says the total revenue of trans machinery rental is given by the function R of X equal to 300X minus 0.4X squared. Where X is the number of units rented, what number of units rented produces the maximum revenue? So again, looking for the X, so negative B divided by 2A. I'm going to put this in the correct order, so negative 0.4X squared plus 300X. So this would give me negative 300 divided by 2 times negative 0.4. So that's negative 300 divided by negative 0.8. So I do 300 divided by 0.8, and I get 375. So again, I'm looking for the amount of rooms. So in this case, 375 is the answer I'm looking for. All right, let's do one more. I say one more, there's two more. Let's look at 44. So this one's the total cost of producing a type of small car is given by C of X is equal to 9,000 minus 135X plus 0.045X squared, where X is the number of cars produced. How many cars should be produced to incur the minimum cost? So again, that just means that we are looking for the vertex. So I'm going to start with the X. So that's going to be negative B divided by 2A. Again, it helps to write this in the correct order. So I get negative 135 divided by 2 times 0.045. That gives me positive 135 over, for sure that's just 0.09. I'm going to verify. So that's 0.045 times 2 is in fact 0.09. So I'm going to take 135 divided by 0.09, and it's 1,500. So in this case, 1,500 cars is what will maximize my or minimize my cost to have the smallest amount of cost. I need to sell at least 1,500 cars. All right, last question. Number 47. In this one, we're going to use the equation h of t. We've seen this one before. Equals negative 16t squared plus v naught times t plus h naught. Where height is, for the height, for t is time, v naught is the initial velocity, and h naught is the initial height. So number 47 says sit in a tree 48 feet above the ground level. So that's going to be your initial height. Sue shoots a pebble straight up with a velocity of, so 64 would be my initial velocity. What is the maximum height obtained? So we're going to plug this in. So it's going to be negative 16t squared plus 64t plus 48. So again, I'm looking for the maximum height. So that would be h of t. So I got to find out what time that happened at. So negative b divided by 2a. So negative 64 over 2 times negative 16. So that's negative 64 over negative 32. So that's positive 2. So it happened in 2 seconds. Yeah, it happened in 2 seconds. So now I got to take that and plug it in. So what is the height at 2 seconds? So that'd be 2 squared plus 64 times 2 plus 48. So that's going to be 4 times negative 16 is 32, 64. So that's negative 64 plus 128 plus 48. Oh, man. I'm just going to pull up the handy dandy calculator here. All right, so that's going to be 128 plus 48 minus 64, and it's 112 feet. So 112 feet would be my maximum height. Right? So all it is just trying to calculate that vertex. Gives you a lot of information there. That is pretty much it for 4.3. So if there's anything else that you need out of this, please continue to email me. Other than that, I will see you in the next video. Bye for now.